Right, we have to work out angle BAC of this triangle here. BAC. Now I'm going to show you two ways of doing this. The first one involves all the equations involving non-right angled triangles, and the second way will involve sine, cos, tan. So we have to work out BAC. Now we're told two sides and an area. That's interesting, it's slightly different. So look at your formula sheet, or preferably, if you know them in your head, just write down the equations which are related to non-right angled triangles. It's the cosine rule, the sine rule, and the formula for the area of a triangle. And look at which one links two sides and the area. It's this one. Area, A and B, two sides, that just leaves one unknown, which is an angle. So immediately you can use this to work out an angle. Now, as it's written, it's half AB sine C. Well, A is opposite the angle A, we know. B, opposite angle B, we don't know. And sine C, we don't know and don't really care. So we have to rewrite this involving the two sides that we do know. We know C and A. So we're going to use area is half AC sine. Now AB sine C, AB sine C, you can think of this as two sides and the angle between them. So AC and the angle between them is B. Right, we can work with this. So we know the area, we know A, we know C, so we work out B, that angle there. Okay, put in the numbers. Area is 18. Half times A is 8 times C is 7 times sine B. Okay? Therefore, sine B, just using algebra to rearrange this, sine B is 2 times 18 over 8 times 7, which is 36 over 56, 0.642 something something something. Put that in your calculator's memory. Throughout the whole of this, we're always going to use the exact value from your calculator's memory. Right, so therefore B is the inverse sine of 0.642, which turns out to be 40.0052. Something, something, something. Very close to 40, isn't it? Now, you can work with exactly 40 degrees from here on if you want, but it's much preferable, again, to get that in your calculator's memory and work with the exact value, 40.0052, whatever. So again, get that in the memory. So that's B. I'm just going to write it as 40 here, but we're always going to work with the exact value from the memory. Right, good. So now we have two sides and the angle between them. Let's go back to our equations and see what we can do with that. Well, look at this one, the cosine rule. Two sides, BC, and the angle between them, A. So we know everything on that side, which means we can work out another side. Again, we have to rewrite this because we don't have B and C, we have A and C. So we shall rewrite that as B squared equals a squared plus c squared minus 2ac cos b. Right, we're going to work out b because we know all of this. So b squared equals 8 squared plus c squared is 7 squared minus 2, use brackets when substituting, 2 times 8 times 7 cos 40. But again, we're going to use that value, the exact value. Therefore, b squared equals, put all that in your calculator and you get, I tell you what, I'll just show you the difference between using 40 and 40.0052. It turns out that squared plus that squared is 113. If you use 40, this lot comes out at 85.796 something something. 96 something something something. Okay. So that's, I'm going to put this in brackets. That's using exactly 40 degrees, the wrong way. Okay. If you use the exact value, this is 85.790. So you see, not much of a difference, 796, 790, but it's possible in many questions that a small difference can make a difference between a decimal point mistake at the end. So always use the exact value. Yeah. Okay, so here we are, that's correct. So that turns out to be 27.209. Something, something, something. Take the square root and we get 5.216. 5.216, something, something, something. Get that in your calculator's memory. B is 5.216. Okay. Right, we're getting somewhere. We have all three sides and an angle now. So we want this angle and we know the opposite side. We know that angle and the opposite side. So this draws us to the sine rule next, because we can say that the angle we want over, which is A, or rather 8 over sine A, is equal to B, 5.216, over sine B, over sine 40. So let's do that. Let's do it here. So A over sine A, 8 over sine A, thing we want, is B, 5.216 over sine B, sine 40. So we're going to have to dig out the 5.216 and the 40 from your calculator's memory. So rearrange that and you get sine A is 8 times sine 40. Sine A is over 5.216. Put that in your calculator and you get sine A is 0.985 something. something. So therefore A is sine to the minus 1 of 0.985 something whatever. Therefore, angle A turns out to be 80.375. Something, something, something. And we have to give this to 1 decimal place, I think, or 3 significant figures. Can't remember which. So the final answer is 80.7 pushes a 3 up to a 4. Okay. Degrees. And that's it. A very respectable way of doing it, using the non-right-angled triangle equations. So now, let's move on to a different way of doing it. I've redrawn the triangle here, just rotated slightly, so BC is flat. The reason is, we're going to treat that as the base of the triangle and drop a vertical in there. So that and that is a right angle. Because now we have the area, we still know the area of course, and we know the base of the triangle. And we can use the equation that the area is half base times height. Half times base times height. So, the area is half times the base, which is 8, times the height. We don't know the height, and that's what we're going to find out, so we'll call it h. But we do know the area. So the area is 18, is half times base times height. Okay, therefore rearrange to get h. Height is 2 times 18 over 8. 2 times 18 over 8. And 2 and the 8 cancel 1, 4, it's 18 divided by 4, which is 4.5. Okay, so the height is exactly 4.5. Right, good. Now what have we got? Well, we have a right angle triangle here, and we know 2 sides. So, because we want to find angle A ultimately, we can work out part of A there. And then in the next bit we'll work out the other part using this triangle and add them together at the end. So, this right angle triangle, that's the hypotenuse. This is the opposite because it's opposite the angle. And this side is the adjacent. So we want the sine, cos or tan that connects the hypotenuse because we know it and the adjacent because we know it. Hypotenuse and adjacent is cos. So let's call that y. Cos of theta, which is y, is adjacent 4.5 over the hypotenuse, which is 7. I haven't turned the microphone on, have I? I haven't turned the microphone on. You can't oh, you can, thank God. I'm not an idiot. Amazing. Should have just kept going. Anyway, cos of y is 4.5 over 7. Right. Which is 0.642 something, which is 0.642 something something. get that in your calculator's memory. So you can do y is inverse cos of it, 0.642. So we get y is 49.994. 49.994 degrees. Get that in your calculator's memory, as usual. Okay, so y 49.9 something degrees. All right. What next? Well, we need to work out this angle. So we're looking at this smaller right angle triangle next. We don't know B, but we can work out this if we knew this, because we know the whole thing is 8. So we can work out this distance using Pythagoras, because we know this and this. So what should we call it? Let's call it x. So Pythag, the big one, hypotenuse squared, which is c squared in this case, is equal to the other two squared and added. So in this case that's h squared plus x squared. Therefore x squared is c squared minus h squared. That squared is that squared minus that squared. This is just basic Pythag. Therefore x squared is c squared is 7 squared, which is 49, minus 4.5 squared. And x squared turns out to be 5.361. No, that's x, sorry. X squared is 28.75. Take square root. X is, what did I say? 5.361. 5.361, something, something, something. Get it in your calculator's memory. Okay, so we know x, therefore we can work out, let's call it P. Why not? P is just going to be, do it there, I'll do it here. P is 8, the whole thing, minus x, 8, which is 5.361, something, something. Use your calculator's memory recall and you get P is 2.638. 2.638, something, something, something. Get it in your memory. Okay, 2.638. Right. We want this angle here. Let's call it Z. We have a right angle triangle. We know that side and we know that side. And we want an angle. Brilliant. We just have to use sine, cos, tan and we've got it. So, which of these connects? Well, let's label it first. So this time, the hypotenuse is that side. That's the angle we want. So this is the opposite. And this must therefore, by coincidence, be the adjacent again, because it's touching the angle and the right angle. So we know the adjacent, it's 4.5, and we know the opposite, it's 2.638. Which one connects the opposite and adjacent? It's tan. How exciting! So tan theta, and theta is z, is the opposite, 2.638 over the adjacent, which is 4.5. So tan of z is 0.586. Put it in your memory, something, 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 so we can use it to work out z, which is inverse tan of memory recall, 586 something something, and z, therefore z equals, turns out to be 30.380 degrees. Something degrees. Okay, almost there. We've worked out y, we've worked out z, 30.380 degrees. So angle A is just y plus z. So A is 49.994 plus z 30.380, and this is where your memory recall and mastery of your calculator skills is important, because if you are not using the exact values of these, it's possible that you end up with 80.3 or 80.5 instead of 80.4. So using a memory recall to dig that out and that out, you get 80.375 something, something, something. So A to 3 sig figs or 1 decimal place is 7 leaves, it does not leave alone, 7 pushes up that 3 to a 4, 80.4 degrees. And I apologise for my appalling language earlier. So, both ways, perfectly acceptable. Both get you the correct answer. I think this is the more professional way, but you can do it like this way if you like. What do you think? Difficult question, last question on the exam sheet. I think it was a challenging question, yes. But you've got these formulas in your formula sheet. You should know them anyway, of course. Likewise, you should know these anyway, and the formula for the area of a triangle, both of them. As long as you're neat and organised, it really helps when you write them down on the sheet in front of you. Then no reason why you can't nail this question.